The purpose of the analysis presented in this video is to refine the chronology of the Old Copper Complex by analyzing dates from a variety of contexts. We discuss potential reasons for some of the dating discrepancies and confirm that archaic societies in Lake Superior produced one of the oldest metalworking industries in human history. The Old Copper Complex refers to the long tradition of copper use by Native American societies in North America during the Archaic period. Copper artifacts associated with the Old Copper Complex have been found throughout the Great Lakes region, with the greatest concentration around Lake Superior in Wisconsin, Minnesota, Ontario, and the Upper Peninsula of Michigan. The Old Copper Complex is characterized by the production of large utilitarian copper technology, including knives, projectile points, and axes. Archaeological, geological, and metallurgical trace element analyses indicate that native copper was procured from the Lake Superior region through surface collection of float copper and or subsurface mining of native copper veins or outcrops. In this video, I use slightly different terminology when describing time. The phrase CalBP is used as shorthand to refer to calibrated radiocarbon ages in years before present. Whereas in this video, the use of the shorthand before present or BP alone means radiocarbon years before present. See citations and references within the paper if you need more information on calibrating radiocarbon dates. Because the Old Copper Complex spans millennia and involves distinct hunter-gatherer societies, its timing has not been easy to delineate. To address this problem, we present a comprehensive analysis of all published radiocarbon dates associated with the old copper mines and copper technology in the Lake Superior region, as well as provide 8 new radiocarbon dates. Since the suite of published and new radiocarbon dates were obtained from a variety of materials, an issue that could potentially influence the conclusions, dates were grouped by archaeological context and material. First, we had wood and cordage found embedded in or wrapped around copper artifacts, which we interpret to represent the timing of discard or the point of loss during use. The second grouping is organic matter stratigraphically associated or found in the same horizontal stratigraphic layer with copper in excavations. The third group is charcoal and bone from cremated burials with copper grave goods, which we interpret to reflect the timing of the transformation of the artifact from one use realm to the other. The fourth grouping is wood and charcoal recovered from infill materials at the bottom of prehistoric copper mines on Isle Royale. The purpose of the analysis presented in this video is to refine the chronology of the Old Copper Complex by analyzing dates from a variety of contexts. Artifact radiocarbon dates were compared with previously developed sediment-based records of copper mining pollution, for example lead, from 6 lakes in the Michigan Copper District area to assess the relationship between the 2 lines of evidence for the timing of the Old Copper Complex. We discuss potential reasons for some of the dating discrepancies and confirm that archaic societies in Lake Superior produced one of the oldest metalworking industries in human history. The Old Copper Complex encompasses a series of mobile, egalitarian hunting and gathering cultures that differed in burial practices in bone and lithic tool industries. These cultural groups were linked by a common knowledge of native copper extraction and metalworking, which allowed them to produce utilitarian implements, weapons, and ornaments. Old copper complex derived copper artifacts have been collected from the surface or excavated from occupation sites in ancient copper mine pits. The origin of the raw native copper material is presumed to be glacial float copper and bedrock deposits surrounding Lake Superior, as evidenced by thousands of prehistoric copper pits and fissure mines. The bulk of native copper artifacts include items for hunting, fishing, and woodworking, such as spear points, harpoons, fish hooks, adzes, wedges, awls, and drills. Items of symbolic use or personal adornment are uncommon, with beads, bracelets, and rings having been occasionally found. Considering the wide geographic dispersal of copper artifacts, a sophisticated mechanism of exchange and trade is surmised to have existed during the Archaic period. The development of radiocarbon dating by Willard Libby in 1946 allowed for the direct dating of organic material associated with copper use. Libby in 1954 was the first to radiocarbon date charcoal found in cremated burials containing old copper complex grave goods from the Oconto site in Wisconsin. The Oconto site is an old copper complex cemetery originally excavated in 1952, which consisted of both individual and multiple burials with grave goods. The radiocarbon analyses revealed dates of 5,600 years before present, which were initially met with skepticism by researchers who argued that the site should date to the Woodland period. However, subsequent radiocarbon measurements at Oconto resulted in dates of 7,500 and 4,500 BP, supporting Libby's original findings. Work by Crane in 1956 expanded the number of radiocarbon measurements associated with the old copper complex by dating charcoal and wood preserved at the bottom of copper mines on Isle Royal. These dates range from 4,400 to 300 BP, thus extending the potential age range for copper exploitation to younger periods. The development of accelerator mass spectrometry radiocarbon dating made it possible to measure smaller masses of organic material associated with copper artifacts. Native copper is a known bactericide and fungicide that happens to preserve organic matter. Bukins et al. In 1992 were the first to employ AMS techniques to date organic matter preserved with copper artifacts in North America. Until recently, a radiocarbon date of wood embedded in a copper projectile point from South Fowl Lake was considered one of the oldest reliable dates for worked copper in North America. However, more recent AMS dating of wooden shafts embedded in copper projectile points from Vilas County, Wisconsin, produced even older ages. Copper has been found in association with OCC-era bundled burials and partial cremations from the Osceola site in Wisconsin. Two pieces of charcoal stratigraphically associated with burials at the site had dates of 4,000 and 3,400 BP. In general, these ages and other radiocarbon measurements suggest that copper use in the Lake Superior region occurred over thousands of years, beginning in the early Archaic period. Many old copper complex era copper mines are located near small inland lakes on the Keweenaw Peninsula and Isle Royal. Previous experimental and crystallographic evidence has shown that the native copper ore was likely processed and worked into usable forms by heating with fire and working with stone hammers via a process known as annealing. Lakes are sensitive recorders of environmental change and therefore can be used to detect emissions from nearby metalworking activity. In 2013, my colleagues and I were the first to use lake sediments to reconstruct the timing of prehistoric copper mining and annealing emissions in Michigan. While the native copper in this region is of high purity, trace metals are found in the raw copper ore. and the surrounding bedrock, and in wood smoke emitted during annealing. Lead volatilizes at temperatures found in wood fires, causing it to become airborne. Our 2013 paper proposed that lead was released into the air along with wood smoke during annealing and subsequently deposited in nearby lakes and retained in the sediment. This work was expanded upon in 2015 to include other elemental proxies and an additional sediment record from Isle Royale. We assembled radiocarbon dates associated with work copper and copper artifacts typical of the old copper complex from the Lake Superior region. We included 7 new radiocarbon dates of wood and cordage embedded in copper artifacts and 1 date of charcoal found in stratigraphic association with worked copper. The dates were grouped according to context, and the median age for each calibration distribution was calculated along with 95% confidence intervals. For each of the 4 groupings of radiocarbon ages, the probability density functions were summed in order to calculate cumulative probability distributions and a median estimated age for each grouping. Artifact radiocarbon ages were compared with 6 lake sediment records from the Michigan Copper District and 1 control lake from southeastern Minnesota known as Lake Pepin. Using 3 lakes from the Keweenaw Peninsula and 1 site from Isle Royale, research presented in previous videos suggests that lead concentrations in lake sediments are sensitive to both historical and prehistoric emissions from nearby metalworking activity. Like the previous videos, enrichment factor equations using titanium, magnesium, iron, and organic matter as references were applied to generate 4 lead enrichment indices. The indices were averaged to produce a mean anthropogenic enrichment factor, wherein values less than or equal to 1 are considered background levels. The sediments were dated using a combination of lead-210 and radiocarbon measurements of terrestrial macrofossils. More detailed information regarding the study lakes and sedimentary analyses can be found in the 2013 and 2015 papers I covered earlier in the video series. The stratigraphically associated dates are the first grouping. For the most part, they are tightly clustered around the median summed probability age of 3600 Cal BP, with 9 dates 1000 years of the median, 2 that are younger, and 1 that is much older. Organic material stratigraphically associated with copper is susceptible to mixing, potentially confounding radiocarbon results. In addition, stratigraphically associated materials may have been remobilized by natural processes or deposited after the abandonment of the copper artifact. The second grouping is dates from copper mines on Isle Royale. Radiocarbon dates of wood and charcoal obtained from the bottom of prehistoric copper mine pits have been used to estimate the age for copper mining on Isle Royale, with early research proposing that they should reflect the period of active copper mining. The ages from the copper mines have a distinct bimodal distribution, with a separation of about 3,000 years between the 2 modes. The median sub-probability age of the mine dates is 3,500 Cal BP, which is similar to the median summed probability age of the stratigraphically associated dates. The third group is cremation dates. Cremation burials directly associated with copper artifact grave goods are generally older than dates found in stratigraphic association with copper artifacts and dates from mines. 5 of the 7 cremation ages are within 500 years of the median sum probability age of 6,400 Cal BP, while 2 from the Oconto site are substantially older. These 2 anomalously old cremation dates were analyzed prior to the development of AMS and current techniques. Radiocarbon analysis of cordage wrapped around a copper grave artifact returned a date of 6000 BP comparable to that of charcoal 5200 BP, taken directly from cremated burials. From the old copper complex burial site known as Osceola, however, two radiocarbon dates of charcoal are younger. This is probably due to radiocarbon ages at Osceola being taken from an associated stratigraphic layer, which, as discussed above, can produce anomalously young ages rather than from material directly associated with burial deposits. The fourth group is embedded dates. Embedded materials can be used for dating the timing of copper use because the weathering products of native copper oxidation are natural fungicides and bactericides that preserve organic material for long periods of time. The embedded age distribution is different from the mine and stratigraphically associated date distributions in that there are no large clusters of similar ages, but rather a large range that spans a much greater time period than that of the other contexts. For example, the oldest age is around 8400 Cal BP, and the youngest age is around 1400 Cal BP. There is a small cluster around the median subprobability age of 5300 Cal BP, with 13 of the 18 embedded ages dating to before 5000 Cal BP. Three radiocarbon dates of embedded organic material are anomalously young. For example, a leather bag containing copper found on the Keweenaw Peninsula dates to about 1500 BP. However, no base treatment was applied to the leather prior to radiocarbon analysis, which can result in anomalously young ages. In addition, two radiocarbon dates of wood embedded in conical copper projectile points exhibiting a typical old copper complex shape have relatively young ages. One is a copper projectile point found at Washington Harbor on Isle Royale that dates to the Archaic Woodland Transition period, although the point was found on an Archaic period paleo shoreline of Lake Superior, while another is a copper projectile point recovered near Wisconsin River that dates to around 1800 BP. Since the other reported radiocarbon dates of conical projectile points are older than 3600 Cal BP, we propose that the organic material embedded in these old copper complex style artifacts may have been contaminated after artifact abandonment, during excavation, during transport, in storage after excavation, and or pre-treatment prior to radiocarbon analysis. It is also possible that the projectile points are older than their associated dates but were reshafted and reused during later periods. When the three anomalously young dates are excluded, embedded organic materials associated with copper artifacts have a median summed probability age of 6500 Cal BP. Radiocarbon dates obtained from embedded organic material in cremated remains are contemporaneous with increases in lead concentrations from around 9,500 to 5,000 Cal BP in sediments from 6 lakes on the Keweenaw Peninsula and Isle Royale. The study lakes are located near prehistoric copper mines and are sensitive to heavy metal inputs from historical human activity. While the copper is of high purity, lead is found in the native copper ore at around 1% concentration, as well as in the surrounding bedrock and in wood smoke emitted during annealing. These levels of lead are consistent with the relatively small increase in lead detected in sediments from lakes across the region. In 2013, we proposed that lead was released into the air along with wood smoke during mining and annealing and deposited in nearby lakes. Therefore, increases in lead in the sediments are interpreted to reflect the intensity of nearby copper mining and annealing activities. Middle Holocene lead increases were not found in the sediments from Lake Pepin in southeastern Minnesota, suggesting the source of lead was localized to the Michigan Copper District area. Exact timing of the lead increases in the Michigan Copper District area appear to be different at each lake, consistent with the hypothesis that the lead deposition signals are uniquely associated with local metalworking activity. The correspondence between the embedded and cremated radiocarbon ages in sedimentary lead concentrations in lakes near prehistoric copper mines provides strong evidence that embedded radiocarbon dates, not mine and stratigraphically associated dates, reflect the actual timing of the copper mining industry associated with the old copper complex. We suggest that the radiocarbon dates from mines and in stratigraphic association with copper artifacts likely reflect the timing of post-abandonment and transformational processes. An evaluation of all radiocarbon dates associated with the old copper complex technology suggests that the type of material dated in archaeological context are important when applying radiocarbon data to establish the relationship between sites and artifacts. The radiocarbon data show that, with a few exceptions, the ages of organic materials embedded within or wrapped around copper artifacts are older than both the ages of organic matter found in stratigraphic association with copper artifacts and radiocarbon dates from the bottom of prehistoric copper mine pits. This suggests that dates from layers in stratigraphic association or from the bottom of mine pits are likely affected by post-abandonment transformational processes and therefore are not reliable indicators of site occupation and future use. Conversely, organic material found directly in contact with a copper artifact appears to be ideal for determining the timing of use because the weathering products of native copper oxidation preserves the integrity and context of the organic material. Embedded radiocarbon dates from copper artifacts display a strong correspondence to the ages of lead increases found in sediment from nearby lakes, reaffirming that these dates reflect the actual timing of the peak of the copper industry around Lake Superior. Taken together, these independent lines of evidence indicate that during the Archaic period, a copper mining industry emerged around Lake Superior, in some places multiple times, which was intensive enough to produce a signal detectable in lake sediment geochemical records. Radiocarbon dates from cremations and embedded material, along with increases in lead in sediment from several lakes across the region, converge on a time period sometime between 7,000 to 5,000 cal BP. We propose that this marks the timing of the peak in the ancient copper mining industry, an assertion supported by previous research. The radiocarbon ages presented here and by William Reardon in 2014 push back the oldest known copper artifact age to at least 8,500 cal BP, demonstrating that the old copper complex is among the oldest reliably dated metalworking industries in the world.